Okay. So what we're going to do is we're going to look at some systems by graphing them. Then we're going to drop the graphs and start doing algebraic. So here's example 1. We have y plus 3x equals 0, and then we have y minus 6 equals a negative 3x squared. So for today's stuff, one of them is always going to be a line. The other one's always going to be something else. So for this, what kind of graph does this bottom equation make? It is a parabola. Let's go ahead and set up the parabola. Guys, we're going to go ahead and make y equals for the parabola. So the 6 is getting moved to the other side. What term is missing from that? The b. And do you guys remember what kind of form it's in when the linear term's missing? Both of them. Yes, yes, yes. So standard form and vertex form. Speaking of vertex form, what is the vertex of that graph? Yeah, and does it open up or down? It opens down. All right. So let's go ahead and plot that vertex. And then remember, we're going to use our little pattern here. And this is for the parabola. Okay, so what was I going to ask you? Yes, I was going to ask you what happens when I move one place away from the vertex. It's 3 up or down? Yeah, it's 3 down because of course it opens down. But remember, it would be 1 squared times the a value, and that would give you the sideways movement or the up and down movement. Let's do another point. Let's go 2 places away from the vertex. 2 places squared is 4. 4 times negative 3 is going to tell us our down movement of 12 units. And then guys, go ahead and grab your symmetrical points, and then we will draw the curve. Any questions on how I got these points? And the best that you can, try to draw a very pretty parabola. I know yours looks way better. Of course, or the top equation, of course, is a line. Y'all, I'm going to push the 3x over. It's going to be in slope-intercept form. So I'm graphing y equals a negative 3x. Obviously, it goes through the origin. Okay, so let's see if I do not have to exit full screen. I do want a line, and that will work for me. And I take it back, it doesn't work for me. Okay, so obviously you guys can see that it intersects the parabola at how many points? So if I happen to, I don't know, test or quiz you on this by graphing, let me show you how to get your full credit. So obviously it intersects at 2 points. So I am going to put a box around where it intersects on my graph. And I might even use a highlighter because I just don't want my teacher to miss that. So it intersects here. It intersects here. And I want my teacher to see that. So I put a big box around both of those. I'm even going to write the ordered pairs. Like, I do not want her to miss that I know what I'm doing on this and I've got full credit. Remember, ordered pairs are solutions to the system. So one of the solutions is going to be a -1, +3. And the other solution is going to be a +2, -6. And remember, solutions to systems is that we would plug in those ordered pairs and we would get true number sentences for both of those equations. Any questions on that? Okay, well, if there's not a question, let's do it all over again. Let's do example 2. So for example 2, we have another parabola and a line. Y'all, let's look at the bottom equation. And I want to know if your Algebra 1 teacher taught you the cover-up method to graph. Anybody remember the cover-up method? So listen, the cover-up method is super easy. What we're going to do is we're going to find the x-intercepts. And when we find the x-intercepts, we are literally just going to cover one of these up. So if I cover up the x value, I'm going to solve for y. Right now, -y equals a +6. So what does y equal? -6. So let's draw a dot on the -6 for the y-axis. And then literally it's called the cover-up method because we just cover up the other one and solve for the x value. Y'all, what does x equal? That's it. And you guys know you only need 2 dots to make a line. So once I put a dot on the +6 on the x-axis, I'm ready to graph this line. I don't want to waste time trying to make my lines perfect. Okay, so now we're going to go ahead and focus on the top equation. The top equation, of course, y'all, is a parabola, but what kind of form is that in? It's nothing. So remember, that's not vertex form. It's almost vertex form. What would we do to make a vertex form? Yeah, just push the 1 over. Okay, so we're going to graph y equals 1/2 x minus 3, close it, square it, minus 1. So our vertex is at +3, -1. And then y'all, is this graph going to open up or down? Okay, yes. So it's going to open up and our lines underneath it, like it might not cross, but I don't know how wide the parabola is. So you still need to graph it and look at the shape to make sure. There might be no solution, but we're going to double check. So let me make my sideways movement chart. And guys, my A value is a fraction and the denominator is a 2, which means I'm going to plug in ordered pairs that give me lattice points. Or what I mean is I'm going to plug in sideways movement that's going to give me lattice points. So I'm going to go 2 places away from the vertex, and I'm going to square that movement and multiply that by 1/2. So that means I'm going to go up 2 places. Okay, let me do one more point. Let me go 4 places away from the vertex. 4 squared is 16 times 1/2. That means we're going to go 8 places up. I think that we can safely say there's no solution to this. So let's write no solution. Do you guys have any questions on why it's no solution? Yes. Undefined really only means when there's a 0 on the denominator. That's all undefined means. Let's talk about, like, if I try to solve this algebraically, I would end up with a quadratic equation that would have a discriminant that's negative. I'll talk more about that. I don't know if that's kind of what you were trying to get at, but there are going to be times when we're going to solve this and we're going to have to use the discriminant to confirm there's no solution. Let's talk about that now, actually. Where's my arrows? They're way over here. Okay, so let's talk about this, guys. So we're dropping the graphs. We're going to solve algebraically. Here's the good news. Remember, one of them is always going to be a line, so you're always going to use substitution. Whatever the line is, we're just going to substitute that into the other equation. So where I see the letter y, I'm going to drop in x plus 5. So here we go. I'm recopying the original top equation. Where there's the letter y, I am going to put in x plus 5. Remember your order of operations. I need to clean up what's going on inside those. Think about order of operations. Do you mean FOIL? Yeah, you guys have to expand. That's a perfect square trinomial. You have to FOIL that out. So you're going to do x times x times 5 halves, another x times 5 halves, combine like terms, and then 5 halves times 5 halves. Then you're going to distribute the 4. Don't distribute until you FOIL. All right, let me change color because color is fun. So when you FOIL out that perfect square trinomial, guys, you get this. Now let's distribute. Okay, listen, we're not like finding x-intercepts, but we are solving a quadratic. And every time you solve a quadratic, it has to be set equal to 0. Yep. So let's push that x and that 30 over. Minus x minus 30. And then from here, check to see if it's factorable. If it's factorable, then there's solutions. If it's not factorable, listen to my verbal instructions because I'm not going over one like this. If it is not factorable, then you need to check the discriminant. If the discriminant's a positive number, then you're going to have to solve by completing the square or the quadratic formula. If you do the discriminant and you end up with a negative number, stop, write no solution, and move on. We're not solving this with like the letter I's and stuff like that. We're either going to factor it or we're going to use the completing the square. So most of the time it's going to be factorable. This is factorable, guys. What are we going to use for factors? Remember, we multiply A times C, so that's going to be a negative 20. And then I've got a positive 19. What numbers do I put in the sides of my X? A 20 and a negative 1. Good. So I'm going to factor by grouping. -5 and a +4. That's good. Don't box that in. Remember, we're solving a system. We have to go back and figure out what y is. But the good news is I got a pretty simple equation right here. I already started. I'm going to start that again. We're just going to plug in those x values and solve for y. So x minus 5 is going to give us our answer. No problem. So here's x plus 5. So one of the solutions, guys, is going to be -5, 0. Now let's plug in the fraction. So 1/4 plus 5 equals 0. I'm going to make that into fourths. So the other solution is a +4th and then 21/4, and just leave it as an improper. It's fine. So again, I really want you guys to remember that you might have to use the discriminant to check if there's a solution. If you want to jot that down real quick, because that's the second time I've said it, and I'm even like saying you might want to write that down. There will be times when you are given a system just like the one I worked with you, where you might get stuck and get bogged down in some stupid calculations when you could have just checked if it was a real solution or not by checking the discriminant. Do you have any questions on this? So I have just a few more minutes. I'm going to skip over some because I want to talk about that. Look at example 5. Y'all, absolute value is coming back. Snap out of it. We're almost done. Don't be sleepy. How can you sleep? I mean, we're doing absolute value equations. What are you doing? All right, so they both equal y. Y'all, I'm going to drop in 2x minus 4 for that y value. When you guys have x's on both sides, things get a little tricky. You might have an extraneous solution if you get absolute value to equal what kind of answer? Right, negative number. So we're going to solve this and then we have to check for extraneous. All right, let's solve. Oh, absolute value. I love absolute value because I get to solve this twice. Man, original, opposite. Solve it twice. Back over here on my original, I'm going to move these x's and move that -11. Plus 11, plus 11. All right, let me do the opposite. I'm going to add x to both sides. The 11 is still getting moved. So we have two answers because it's absolute value. You always have two answers. We have a 7 and we have a 5, and one of those is extraneous, y'all. Which one is it? It is the 5. How'd you know? Yeah. If I put that 5 in on that right side of the equal sign, I'd get a negative value. I'd get -1. Cannot be negative ever. I'm going to draw a line through this. So what that means is we only have one intercept, and I know the x value is a 7. So I'm going to plug this 7 in right here, get that y value. The y value is just a 10. Box that in because that's the solution. Yes, ma'am. Because see my arrow right there? If I put that 5 in right here for the x, I'd get 10 minus 11, and that's a -1. And remember, your absolute value bars cannot equal any kind of negative whatever. So that's why it's extraneous. Okay, friends, the bell is about to ring. Told ya, you do have homework. I am taking it for a grade. Suck it up, Buttercup, because you don't have homework tomorrow night. So this is the last homework that's pretty heavy. Have a great afternoon. Goodbye. Bye, KVA. I'll see you later.